Good evening, or good afternoon. Welcome to Classically Schooled on Twitch and my YouTube channel as just plain old me. I do apologize for being late. I could not figure out how to adjust the schedule on my phone because both YouTube and Twitch send you from their mobile sites to their apps, and neither their mobile sites nor their apps will let you change the scheduled time. And lunch was way later than I expected. In fact, it was so late, it probably should be considered early dinner at this point. But I am back. I am here. I am in the basement. And I have a solder practice kit that we are going to take a look at. Because one of my coworkers thought I needed schooled on soldering. Ha ha ha. Which, if you saw some of my streams the last week, you might think that's the case. But actually, we got to talking and he agreed that last week I just had a whole bunch of what he wanted to call a comedy of errors, but we quickly agreed it was more of a comedy of malfunctions. Because no one expects your... Yes, hi Toby, welcome. Yes, no one expects that your rework station will turn into a destruct your board station, but that's what happened. That was one of the comedy of malfunctions that happened last week. Also, actually, that rework station, I think, was at least 2 of the streams that went south was due to that rework station. So if you missed Wednesday's stream, you missed me unexpectedly disassembling the rework station to see how it ticked and see if I saw anything wrong with it. And as my coworker pointed out, a lot of times the problem with those cheap rework stations, or in this case, it was an expensive cheap rework station, is they're not properly grounded, and that's probably why instead of heating the desoldering pump tip, it was both heating and not heating, and apparently when it was in not heating mode, it was in destroy your board mode because it was dumping whatever voltage the desolder heating element used at whatever current, which probably wasn't good. So it killed the ICs on one of the boards I was working on. The good thing is I have ordered parts to be able to continue both projects that got sidelined. Unfortunately, I will not have parts for Music Monday tomorrow, most likely, because I had to order parts from 2 different vendors because of issues with parts availability from my preferred vendor. Usually I prefer to order from Mouser. Not that I don't mind ordering from Newark. They're great. I order stuff from Newark, from Mouser, from Allied, DigiKey, Arrow. They're all great, but I usually like to order from Mouser because they seem to have most of everything I need. But they didn't last week. In fact, some of their prices were way up from normal too. So I may be switching to Newark as my primary vendor because they had more things in stock than Mouser, but not everything. I think Mouser seemed to stock more Nichicon capacitors than Newark did. Newark had them, but they were with lead times. Mouser at least had them even if the price was up. And in some cases, significantly up. Although, granted, Nichicons are a premium capacitor. So I knew I'd be paying for them. But the Zoxbox is worth it because I wanted audio grade capacitors. So anyways, today we are going to go back to the basics and we are going to take a look at this Elenco solder practice kit, model SP-1A. I did attempt to put a link in the description. It should be there on YouTube. I don't know if it appeared on Twitch. If not, on my Twitch profile, I have added a link to, I think I called it the used/mentioned. And I'm actually started a page on my website that I'm going to list everything that you might see on stream. And that way, because Twitch doesn't like it when I put lots of links in descriptions, that way, at least on Twitch, if you're watching there, you can still at least go to a page and it'll be categorized. And in this case, I actually have I think it's the category at the top that I think I called it products listed on, or products shown on Twitch, because things like this won't make the durable part of the list. Because this is more of a well, it might. If I really like this learning kit, I may add a section called learning kits and put things like this in it. So this will be the chance where I'll see if this kit is worth adding to a learning kit section. But at least I'll be able to help my coworker, because he ordered a couple of solder practice kits, and he wanted to have some examples of what they look like when you're done. So that's really why. Plus, it'll give me a chance to try some different solders. So that's why I agreed to do it. It's not because I need. Well, I mean, really, I kind of need to refresh my solder skills. But oh, I'm missing a crazy NASCAR race. Darn. I'm heartbroken there, Toby. In fact, actually, the only time I like NASCAR races is when they get crazy. So actually, I maybe am bummed that. In fact, actually, usually if I could watch the last like 5 laps of a race, it'd probably be all I really want to see. But yeah, so it's okay. You're distracted. I'm first going to yeah. Yeah, that seems like the times when I wish I was watching the race. The times when it gets crazy, because the first 95% of the laps where they're just going and going and going, it does not keep my attention. So yeah, it's okay, Toby, if you're distracted. I was first going to do I would call it unboxing, but this didn't come in a box. It came in a bag. So I guess I'm going to call it an unbagging. Because it's not an unboxing technically. So I was going to kind of see what's in the kit before I start assembling it. So I do know the Amazon currently has it. There's a seller selling it for $8.97 right now. If you want to order it from Amazon proper, I think they're charging like $12. I mean, these aren't that much. I mean, at least taking a peek at what you get before I open it up. Now, ignore this extra solder in here. My coworker gave me so the kit did come with solder, it looks like. My coworker gave me some other solder he'd ordered, so I could try it as well. And then I have the solder I've been trying to use. So I actually have 3 different lead-free solders to try. So ignore that. That didn't come with the kit, but it looks like for a kit, I mean, granted, it's not an assortment of parts. It's actually a kit with what seems like a decent instruction book on the surface. It looks like everything you need other than like the soldering iron. And we'll see. I suspect that you'll probably need something like a pair of wire side cutters, as I want to call them. So actually, I'm already I'm impressed so far by what I saw without taking it out of the bag. Oh, okay. So that is the first question that we will have to answer, is what is it going to make? I do know if you subscribe to Bruce at Brankus Creations website, he likes solder kits that make something practical, and if that's your forte, I don't think this is going to make something practical. However, yes, it does have a 555 timer and a speaker. So this at least passes my uncle test, because I am an uncle, that it might be interesting, or might be something that would actually captivate the attention of younger audiences. Yeah, I will see. I hope it says what it is. So if you're looking for something that might get a child interested in soldering, I know Bruce, I forget what Bruce was making on his stream, but it was some sort of meter, which probably not going to keep the attention of children or younger audiences. Unless they're the next Einstein, it might keep their attention. But this looks like something that, since it makes noise, and probably going to make a varying noise or something, yeah, it might actually keep their attention. Actually, the one thing that caught my eye on the back is it has this little quiz. And I don't know what the answer to this is, because I'm sure this will make more sense when I go through the directions. But I get the impression this is going to teach some sort of electronics concept more than just, hey, we're going to solder something together. Also, considering that it has a 555 timer. So that right there, at least from what I could see without opening the manual, makes this look very interesting. Now, whether this is going to spill its secret on the first page, no, I guess not. But, all right. Let's see. Is it going to... Oh, okay, that's cool. Ah, okay. Yeah, I'm flipping through this, and... Oh, here we go. Here's the theory of operation. This will probably tell us what the kit is. And then I'll go back to what I saw on the board and what the manual was saying that I think makes this a really nice kit. But this is... okay, the solder practice kit consists of a circuit oscillating at 1 hertz. Okay, it's a multi-vibrator circuit. That's actually kind of what I thought this was going to be from the question. I just wasn't sure because I hadn't read this. But in the back of my mind, I kept thinking, I think this is a multi-vibrator circuit, because I think I've seen diagrams like this before, probably from one of the MIMS electronic books, Forced MIMS, that you get that you could buy at Radio Shack back in the day. I think there was something very much like this diagram in one of those books. And that's probably where I kept thinking of multi-vibrator circuit. The solder practice kit produces the sound of the European siren. Okay. So, therefore, it makes noise. Yay. I like noise-making circuits. They're the best kind for an uncle to give their nieces and nephews. Because you know that your brother, or one of your brothers, is going to do the same exact thing to you when you have kids. Because that's kind of the thing brothers do, right? And yeah, if any of my brothers are seeing this, then yeah, they're probably going to start to plot their revenge now, even though I definitely don't have kids now, and I'm not even married, so yeah, they're probably starting to plot their revenge now. Hey, we're going to find a solder kit to really get that, Justin. All right, so the one thing I did notice from the board, and as I suspected, and also I just noticed that the speaker in this bag did confirm that my table is stainless steel, because the magnet was attracted to my table here. So this board on the back side actually has a practice area. So before you start to solder the actual components together, you get the chance to practice. And even before that, it has looks like it actually has a couple pages on. So it's got the parts list, which we'll take a look at what's in the kit. So it's got a resistor value guide, capacitor value guide, some metric conversion tables, handy for using capacitors, and a resistor reading exercise. And then it's got it looks like 2 pages, so I guess 8.5 by 11 front and back on kind of instructions for soldering. And let's see, the one thing I do want to see is, does this say somewhere? Okay, yeah, this is lead-free solder in this kit. Yeah, let's see, the melting point's about 40 degrees higher. Does this say anywhere what temperature they suggest you set your iron to? Because even though it gives the melting temperature from this 400 to 410 degrees Fahrenheit, but due to various reasons, you do need to set your iron hotter than that, because otherwise you will have trouble actually getting the solder to flow, and I think your thermal recovery. But it doesn't seem as if it mentions it. Maybe it says on the solder. So anyways, let's take a look at what's in the bag. And I will use my utility knife carefully. Remember to always cut away from yourself. So we have a PCB, which this is a, so it looks like it's a single-sided PCB. Because there's only, it looks like there's only copper on one side, but it looks like they did put looks like they may have put solder mask on the other side, even though there's no copper, and it's silk screened. So actually, it looks like a pretty nice board. Looking at the board, granted, it's a simple board, but it does, the traces and the pads, they all look clean and neat. So it looks like a very nice board. All right, we have, let's see, there's some parts and more parts and some wire and a 9-volt battery lead and a speaker. So we have it's an 8 ohm half-watt speaker, which is, oh, my overhead rig is not magnetic. We'll set that off to the side. All right, we have some LF99 lead-free solder. It is 99.3% tin, 0.7% copper. And it looks like there's 5 feet of it. And apparently there is a notice for California residents on here, but I do not live in California. So I guess I'm not supposed to know this information because it says notice for California residents. Okay, it does say keep away from children, do not breathe fumes, may cause dizziness, headaches, blah, 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 blah. Well, I do have a little fume extractor on my desk. I'll make sure to use it. Yeah. Looks like the standard warnings on solder. So that's the solder that came with the kit. I don't know, it doesn't look like it's necessarily the greatest solder, but it probably will work for this kit. I mean, this is a rather simple kit. It probably, I think it will do its job, even if it doesn't look like it's the greatest solder in the world. All right, so we have a little component card that has the components. Oh, that's actually pretty nice. So it's got looks like it has the component. Yep. So it's got the component location down the side. They've got the value, but they also have the colors that are on the stripe. And that's actually pretty nice. And let's see, we've got the capacitors here. And okay, I guess because of the capacitors, there's only 2 two types of capacitors. They don't put the locations that these are for, but the board is clearly marked, and this is marked whether it's the 10 microfarad capacitor or the oh, there is a 100. Oh, I misspoke because I think it's under the capacitor, but there does appear to be a legend under these capacitors, and there is 100 microfarad capacitor, but the board is also marked. So there's the 100 microfarad, the 0.2 microfarads, and then 10 microfarads here, and there should be one more 0.02 microfarad out right there. Okay, so the board is clearly marked, and the card is marked. It's kind of hard to see, but it actually is marked under there. So they are marked. It's just not as clear as the resistors because of the way capacitors are when you lay them flat on a piece of paper. All right, we do have a 9-volt battery lead. I will have to go get a 9-volt battery. There's no battery. It looks like there's some basic wire. It's wire. And then there's a few other components. It looks like they include some solder wick. Although if I do need to use solder wick, I'll probably pull out my Goot wick. We've got a 555, and it is a. We'll look at the chip markings in a moment. There's some transistors. Yeah, it looks like it's 2N3904 transistors. It looks like they're the same. And there's a potentiometer, I think that is probably a volume. Well, if I can find the place on the board where that goes. I'm overlooking it. Oh, it must go there. Okay, yeah, that's okay. It goes there. There must be some extra holes on that board for maybe there's more than one potentiometer they've put in the kit. Okay. And I guess just to kind of take a look at the chips in this bag, I will pull out I have a bigger microscope, but for looking at this, it'll be a lot easier to pull the smaller microscope out. And I guess we'll just take a look at see what the chip markings on the chip are. And well, that is the sketchiest ST Microelectronics logo I've ever seen. That is assuming that is an ST logo. It may not be. Quite honestly, it just kind of looks like a generic 555 timer, which is probably fine because it's a learn to solder kit. And then 2N3904. Yep. Again, these kind of look like probably generic transistors. I mean, they're just probably generic parts. And honestly, as unclear as that logo is, I really can't tell. I mean, I can't really tell what that logo is. I mean, I'm stumped. I mean, on one hand, it looks like ST, it's supposed to be ST Microelectronics, but then again, it doesn't look like that. It almost looks like it might be something different. I don't know. I can't tell what it is. It's a generic part. It should work. I don't think I'm too worried about that. Generic solder, totally fine. Now, so this is generic solder. 99.3 tin, 0.7 copper. This is, I think this was Kester K100D solder, so it's more or less 100% tin. That's why it is no clean rosin core solder, but the solder itself, it's K100D. It's 100% tin, give or take trace elements. And then this is the Kester. This is what my coworker usually orders for his electronics lab at home. It's the Kester 96.5% tin, 3% silver, and 0.5% copper. I don't know if this is the diameter he normally uses, but this is the formulation. So this should be decent solder. If I can get my comedy of errors to go away. Although, interestingly enough, I did notice that even though this is lead-free solder, apparently these products contain traces of lead nevertheless. So, but it's probably an amount that you shouldn't worry about. But I guess they do have to disclaim there is a trace of lead. All right, for soldering, I'll be using my Hacko FX888D soldering station, the genuine Hacko tip that I did finally figure out which one it was. If you saw me mix this up with a whole bunch of generic tips, I did finally figure out which one was the genuine Hacko tip. Spoiler alert, I should have pulled out a microscope in the first place, because then I would have seen the laser etched markings on this solder tip. So, but yeah, Hacko, this tip is, okay, you won't be able to see it, but Hacko actually, I wasn't able to see it in the light I had, but knowing that it's there, you could probably see, you can't see the laser etching, but you might be able to see what looks like something's marked there. But yeah, the genuine Hacko tip had laser etched markings on it, and if I just pulled out a microscope, I actually didn't really need the microscope to have seen that it was laser etched, and that would have told me this was the genuine tip. The light on it would have been enough to glint off of the tip and let me see that there was laser etching on it. And then I would have known, because the other tip that looked like this one didn't have that. I would have known that was the Hacko tip. Saved myself a bunch of frustration. So, spoiler alert, actually, the one, I did a stream where I thought I had found the genuine Hacko tip and was having trouble and thought it was the solder. Well, spoiler alert, it actually turns out I had misidentified which was the Hacko tip, because I didn't know it was laser etched. So I will be using this genuine Hacko tip. I have ordered a few more actually from Hacko USA. So hopefully those will be in this week, and maybe next Sunday we'll take a look at those tips and try to figure out which ones work the best. So, and I guess the one other thing I did buy this week, since my rework station decided to be mean, I bought an Engineer SSO2 solder sucker. My coworker had bought one of these, and it actually looked really nice. I liked it. It feels much better built than some of the cheap ones. And the other thing was, the tip is made from silicon, so it can actually, you can get it much closer to whatever you're trying to desolder, because the tip is silicon. So you're probably going to be more likely to successfully desolder on maybe the first attempt, or at least a smaller number of attempts, than the larger, more plasticky solder suckers that don't have a silicon tip, that you can't really set it down when your iron's there. Actually, it's made in Japan. It actually feels like it's metal. And oh wow, I can actually hear it. This is really nice. I'll definitely make sure I put this in my list of soldering supplies that I use. Yeah, this feels really nice. And the sound it makes when you press the trigger. That's really cool. And then it did come with some extra silicon tube. So the thing is you can cut a section as long as you need. Actually, that's really nice. So if I do need to desolder anything, I have a solder sucker. It's made in Japan. It actually feels really nicely made. I don't remember how much it cost, but it was... I mean, it wasn't as cheap as the other ones, but it feels really... It feels like it'll last longer. So, and it did come with directions. I think it works pretty much the same as the others. So yeah, you can actually... So yeah, it's a heat-resistant nozzle, withstands contact with the soldering iron, 350C max. So I guess if your tip's at 350 degrees C, you could more or less touch the tip. Otherwise, though, you're gonna be able to get really close. I mean, you could be able to get really close to your tip, and then be able to, if your tip's higher than 350, and you could probably get close enough that you could basically roll this over your solder joint and be ready to trigger it. Whereas some of the cheaper ones, even that close would be too close because the tip would melt. Actually, that's pretty nice. It is an aluminum body. I mean, it has a nice weight to it. It's not, I mean, it's not heavy, but it has a weight to it. And then, yeah, the plunger. Oh, yeah, here we go. So, it would probably help if I wasn't pushing down on the trigger, but it's small enough I could actually one-handed re-trigger it. Very nice. And I mean, if I was put on gloves, I'd wear a size medium, so my hand's really not big, and it's a nice size, and I can comfortably single-handedly do that. So it's a very nice size for working with. The tip is going to withstand higher heat, and it has a built-in self-cleaning shaft to prevent clogging. So we'll have to put that to the test. I don't remember what I paid for it, but at least it gets this feels like this will be a valuable tool in the workbench test. I'll set the instructions aside, even though I pretty much know. I mean, I know how to use the solder sucker part, but it had the disassembly instructions, so I'll make sure I hold on to those in case I find the disassembly is not quite as straightforward. But it will actually go nicely with my Gutwick, which was also made in Japan. And who knows? I don't know. Actually, the thought just crossed my mind. Nope, this was made by Engineer, and that's Taiyo Electric Industry Company. Okay, I was about to say, it'd be funny if these were made by the same company. Does not appear as if that's the case. Unless Engineer happens to be... No, I think if it was a brand of Taiyo Electric Industry Company, it probably would say on this. Anyways, very, very cool little solder sucker. I think I'll be able to put it to good use. At least the one advantage of the manual type is it can't decide to go from solder pump to current dump mode. All right. So now you've probably heard me blab on long enough before putting things together. So let's get to. Oh, well. All right. Looks like let me. I was just looking at my safety glasses and let me see what I did with my cleaning wipes. They need to be deslarmed. Because it's usually good when you can see through them. And I also noticed the screws holding them together appear to be rusting, so I think I need to buy a new set of safety glasses, so yay. Well, I guess, well, I'll just have to see what I can find. I mean, not like I don't have other safety glasses floating around the house somewhere, but I probably don't want to use my polarized safety sunglasses down in the basement, or I won't be able to see much. So, all right. These will work for now. Let me let them dry a moment. They do smell springtime fresh now. I would like to think that the anti-fog coating that cleaner had is going to prevent these from fogging, but it will probably only prevent them from fogging for 10.7 seconds. Oh, maybe a little longer. All right, so before we begin to assemble and solder the components to the solder practice PC board, we will start first by practice soldering to the double pads on the edge of the PC board. All right. Right, there is one small change I'm going to make here. Well, I mean, I guess I could follow the directions. I usually tin my tips, and I guess this kit, since it doesn't come with tip tinner, it has you put solder on the tip instead, which I guess will work. And I'll humor the instructions of this kit, and I will apply solder to the tip like they say to. But they do have the all right. That should work well enough to at least. Well, it'll at least get rid of most of the shadow caused by the little smoke absorber. Because actually, I'm looking at the name that's printed on it. It says smoke absorber, and that probably is more accurate than fume extractor. Let's see here. I wish this said a temperature to set the solder to. Alright, well, it doesn't say. So one thing that I'll do, since it doesn't say what temperature to set it to, is I'll start at 650 degrees Fahrenheit, because that's what my solder station's set to. And alright, well, we'll give that a try. So it said, so the first step that the instructions said to do was to use these big pads here and use these for solder practice. So I will do exactly that. So we'll apply our soldering iron. And all right, well, so far I got a little bit of solder on the solder mask on that first one. Overall, I guess they look like decent test solder joints. Yeah, the weird thing is, okay. All right. So yep, that's what it wants me to do. I was confused because I'd glanced at something on the page and I thought I was soldering the wrong thing, but nope. The instructions really do want you to. Oh, well. Okay, so that's not the greatest of solder containers. Alright, well, one thing I'm going to do, just out of curiosity, is I am going to try these other two solders on just to see how they flow compared. So this is that Capacitor K100D. It is a no-clean flux core solder. So my iron is still set to 650. All right, the first thing I'm noticing about this solder is, well, actually the other ones do. This solder, the joints look more matte, slightly more pronounced than the, whoops. First ones, but still, I mean, these actually kind of look matte now too that they've cooled. Okay. So that was the Capacitor K100D. And then finally, this is the Capacitor formulation that's so long enough it doesn't have a catchy part number. It just has a big long number. Now, this may not flow at 650 degrees C. Although then again it might. Because the data sheet for this solder says to go 750 C. But we'll see if it flows at 650. Alright, and actually the finished solder appearance is actually even more matte than the first two. Which is fine. The old adage that solder joints are bad if they're not shiny only applies to leaded solder. So actually that does appear to be a really nice... So this is what came with the kit. You can see it looks... You can actually still see on camera that this looks shinier than these, which is the K100D, but these are still shinier yet than this Capacitor. But it's actually flowing really nice at 650. And now the one thing you probably noticed, I haven't added any flux. The instructions for the soldering kit didn't say to. So, I didn't. All right. Now, I guess if, for just to kind of to show off, so this is a no clean lead-free flux pen. So just to kind of to show if there's a difference, I'm going to apply some flux to this last set of pads here. And then this is the original, the solder that came with the kit. And just to, so We'll see if this helps flowing any. Oh, wow. Actually, that did help. Do you see how that solder just kind of flowed to the second pad? Because these pads were connected. So yeah, actually, even though these instructions don't say to use flux, I think that just shows that flux helps the solder flow. So we'll go on to the next direction. So it first had us solder the double pads. So now it wants us to use the single pads, and I think it's talking about these here. So we'll try soldering some of those. And I'll go a little faster. Because there's, well, number one, there's less pad to heat. So all right, so another thing the instructions said to do is, so we're going to give this a try. It said, well, what if you accidentally get a solder bridge? So I am going to attempt to purposely create a solder bridge between these two pads here. So, and it says that all you need to do is wipe your hot iron across them, and it does appear as if that did fix it. Because that is, I think that's one of the purposes of the solder mask. It's there to kind of prevent the solder from, the solder doesn't want to adhere to the mask. So there we go. So that is a row of solder joints with the included solder, which actually is not working too bad. All right, so now for these next ones, I'm going to try these other two lead-free solders. So I'm going to do about half the pads with the Kester K100D. And then I'll do the other half with the other Kester. And I'll try the solder bridge removal method with these two. So let me just try a few solder joints. All right, so these are the two I'm going to try to purposely solder bridge together. And actually, that was a fail. Well, I mean, it was a success, but did you notice how this solder, I guess, because it's got a rosin flux core, it didn't even let me bridge them. I mean, I probably could have if I glommed a lot more solder on. But yeah, that... All right. So actually, that Kester K100D, it actually works pretty good. Although, I have to admit, I usually prefer lead-free solder with some silver in it, but given the price of silver these days, that does make the solder cost more. So that K100D actually seems to be a decent compromise. Because the one thing is with that I've read for lead-free solder is you want to buy a quality lead-free solder if you're buying some. Because that can be the make or break for you having a good experience with it. Okay. There we go. All right. Now, that's actually pretty good looking. It looks like I've got a good temperature on the soldering iron. Good handle of the flux, the solder with its rosin core flux. So I did do the solder bridge activity, although I was able to do it to make solder bridges with their included solder, but with the Kester solders, they didn't really want to stick to the solder mask. So yeah, that's the solder resist. All right. Oh, here we go. So try soldering to the covered pad. You will find that it is impossible to solder. Oh, yeah, okay. So yeah, there's the, so this big pad here, okay, you can probably see it if I hold the board at an angle, but you see how half that pad is covered with solder resist? Or otherwise known as solder mask. So yeah, if I do try to solder on the solder mask. Yeah, see? But yeah. I can solder quite fine on the big pad here. But yeah, the moment I try to drag my soldering iron on the... Yeah. So... Yeah. Yep. So even, yeah, so if you watch, I'm gonna solder this pad here too. Get some solder on it, and then I'm gonna flow the solder over the whole pad. But you see, notice how if I deviate, yeah, the solder resist is resisting the solder. Actually, that's a pretty cool thing this walks you through. Okay, so there are 3 pieces of wire included. Save 1 piece for the speaker assembly. All right, so, well, it looks like 1 piece of wire, but maybe there are 3. Oh, that's 1 piece of wire. Let's see, the 9-volt battery holder is a 9-volt battery holder. All right, well, let's, so it wants me to cut 7 wires that are 1.5 inches long and strip 1/8 of an inch insulation off both ends. All right. I will use my cheap cutters. And I don't have a imperial measurement source down here. So I will do a rough approximation. Let's see, so 1 inch is about 26 millimeters, but I think if I go 25 will be fine. So 1.5 inches is going to be, how about, I'm sure if I do this to 4 centimeters, I'll probably be fine. If I run out of wire, I've got more wire. So now that I've got 1, I'll just cut these. Two. 3. 4. 5. 6. And 7. 7 little wires. And now, now let me see if I can figure out what I did with my wire strippers. Which I thought I brought downstairs. I'm gonna take a quick break to go upstairs and go get the wire strippers. And I'll go get a 9-volt battery while I'm upstairs. So just hold on for a few minutes and I'll be back. All right, welcome back. I now have the wire strippers that I was looking for, and they were exactly where I remembered them being. I Of course, I don't know what gauge wire this is, so... Actually, it feels like this kit has 24 gauge wire in it, according to the feel of my wire strippers. It's not marked. I don't see any markings on the wire. Oh, it's 22 gauge solid wire. Okay. Oh yeah, that would make sense. Because 22 gauge solid uses the same position on the strippers as 24 gauge stranded. So yeah, it's 22 gauge solid. So it said to strip off about 1/8 of an inch, which isn't much, but I guess for what we're doing with these, it doesn't need to be much. And 7. Seven little cut and stripped wires. Alright, so now that we have those, place the iron and the wire on top of the right pad as shown in figure 7. Allow the solder to flow around the wire, then remove the iron and let the solder cool. Okay, and then, so when we're done, it'll look like that. It says you might have to add more solder, but actually looking at my solder pads, probably because I knew what was coming, because I saw it on the page. I think I have plenty of solder here, so I should not need to add any more solder, but so we should. So hopefully, so we'll take our iron and we'll apply it to the solder. And then we place the wire in the solder. And there we go. So if you're wondering what we are creating here, these are wires to nowhere. But that's okay. I think that's a good hallmark of a soldering kit, is that before they have you solder real parts, you get a chance to practice. Well, So those were the solders included with the kit. I think this is the Kester K100D. I have to say this wire is doesn't have the greatest of insulation on it. But I guess for practice, it's okay. Oh. Alright, well, let's try that again. Yes, the most captivating soldering of this whole project. I realize it. But if we're going to thoroughly review this, we need to follow all the steps. Besides, there's a quiz at the end of the instructions. Yeah, if it says anything about the insulation of that solder, it's melting to my gloves. Alright, we'll try that one again. Well, I don't know why, but I'm just having a doozy of a time getting this last wire soldered on. I may skip it, because I'm just making a mess out of wires. Alright, so we got them tacked on. That last one looks really bad. Of course, you can see the insulation melted on the wire, so it's not the greatest wire. Really not that great at all. Hairline cracks. Oh, well. Alright, so now it wants to create some solder bridges using the second row of single pads. Starting from the left side. Well, we'll see if I can even make solder bridges. No, I can't even get them to bridge because of the solder mask. Although I guess I could try adding more solder. That might... No, I can't get them to bridge. Okay. Now it wants me to make some... Alright, so the practice on repairing hairline cracks is not going to work. But I will... We'll do the next one. Where it wants me to put some wires between two of these pads, so... How many does it want me to do? Oh, it wants me to... Alright, well... Wants me to reinforce the solder bridges I just made, which I wasn't able to make. Alright, well, let's see if I can, if that works. Well, there we go. Okay, so I was able to do their repair by putting a little wire in between those two to bridge it. I'm going to cut some. So we'll do the next one here. There we go. All right, well that. I think for this next one I'll actually, because of how short this wire is, I will use some wires to hold it. Oh, that didn't. Oh, looky there. I created a solder bridge where I didn't want one. All right, well, let's cut a little piece of wire. Put it here. All right, so there's our third reinforced repair. I'll cut a little fourth wire. And place it. And we'll solder it. let me add a little extra solder here. That one. And we'll add a little extra solder to this one. All right, and one more repair, quote, quote. All right, well I guess that, considering the solder didn't want to stick to the solder mask, I guess that looks pretty good. And now it wants us to practice six bridges will be made. Okay, now it wants us to create some larger bridges. I'll cut some more wire. I guess I do have to admit I like how this kit does have you practice some repair techniques before you actually start assembling it. Because I guess if you do make a mistake, you'll have a little more confidence that you'll be able to fix it. Well, although I'm having trouble. All right. All right, I'm going to add a little flux because I can tell that in order to, because I got a solder bridge where I was not trying to create one. I think a little flux will help this all to flow. Hopefully get back. Or I will practice with the solder wick. That also works. I'm going to use my goot wick. All right. Now I think we'll that definitely looks better now. Let's see if I now can't get these little solder bridges to solder. Maybe I'm not quite following the directions, but close enough. Yeah, basically I just desoldered my solder blobs, and I'm going to well, doesn't look that great. All right, I'll try another little piece of wire. Or if I had them, I would use some lead, like component leads would also work for something like this if you were actually repairing. I think in order to, if I was going to try a repair like this on an actual board, I would probably try holding the wire like so I could tack it on one side. Well, oh, I just lifted one of the pads on the board. Well, luckily that's a practice pad. Alright, I'm really having trouble getting this repair practice to stick, so I'm going to stop on it. Because honestly, it feels like I don't know if there's something wrong with their procedure, or maybe it's just the fact of this solder they included isn't that great. I mean, I doubt it is. But, alright, so I think I've gone through their rework instructions other than that. Wide gaps part. And removing solder, well, I used my own solder wick for that. So, let's go through the construction. Alright, so first we need to solder the battery connection. So it does say to the red is positive and the black is negative. I'm hoping their wire is better than I think what I'm going to do is I'm going to tin the pads that goes to. Just like their example for these wires there, I'm going to tin the pads, and then I'm going to apply heat while pushing the battery through, or the battery lead through. As for you can learn how to battery, you have to learn how to battery holder. Also, this would probably be an excellent time to try to use my quad hands, but I just realized with the loop-de-loos they had you do on this board, that is actually harder than it seems to try to use my quad hands. Well, that. Well, if I can get the wires to solder. I got the positive on. try that. All right. Well, alright, that's not working out the way I'd wanted it to. So I will pick up my solder. Alright, we'll try this a different way. Going to strip the battery wires longer than they were before so that I have more that I can stick through the hole. Prior to soldering. And then I can trim off the excess like the instructions say. This will also kind of let me bend them over slightly to hold them in place. All right. Okay, so I got the leads through. Not the prettiest, but it should work. I think I will have to say that it is sort of disingenuous that they have you practice soldering wires with solid core wire and then give you a battery holder that is stranded core. But I have it soldered. We have a battery holder. Our noise-making gadget will be able to battery. Yay. Alright. Electrolytic capacitors have polarity. Does it really want me to solder the capacitors? I guess it does. Oh, well, I just noticed that I made a mistake on the battery holder. So I will try it one more time. Apparently, I missed the part because it shows it in the illustration, but it does not say to do it. But I should have put the wires through the I was supposed to do this number, so I was supposed to put the wires through like this. Like so. And then come back around like, well, I'll show you the illustration. It only shows it in the illustration. It does not tell you to do it in the text, but it sure shows you to do it in the illustration. Actually, it just dawned on me. Actually, I bet these will solder better now because they're tinned. Or they'll go through the hole and let me solder them better. So all right, so there's the positive and the negative. All right, and now yep, that kind of acts as a strain relief of sorts. Now I can trim the leads down a little further. But yeah, there we go. It's a strain relief. But anyways, what got me is, so here's the diagram. So it just tells you to solder them in the hole, but it shows them tucked in. But it doesn't tell you to tuck it in. But I caught it because I happened to notice that the speaker directions actually tell you to do that. All right, so now I'll pull out the nicely organized components. And it wants me to attach the ceramic capacitor to C5. Oh, well, that's the one for C4. It's important to apply the correct component to each location, even if you can't see the component name until you pull the component off. So we'll put the C4 one back on, even though I think they're the same value. So here's the C5. It's not polarized. So this goes on C5. So pull the leads through, kind of bend them over to hold it in place, like so. And then we solder. Well, that looks funny. Oh, it's probably fine. All right, looks like C6. Oh, it looks like the soldering order is the order in the circuit diagram, which maybe not necessarily the best approach. So for electrolytic capacitors like this, the instructions do warn you, make sure the stripe is on the negative side as marked on the PCB. I'm going to use my handy dandy patent pending stack two tools on top of each other board holding method. Would probably help if I made sure that my little stack was on camera. So C6 is right here. Oh. And that was, is that a trace? Yeah, I'll have to take a look at that. Alright, so now I need to check the board. Okay, we're fine. I kind of lifted the trace slightly when the solder got stuck to it, the one going between the negative battery and that capacitor, but it looks like I got it tacked down with the solder, so I think we're good. Crisis averted. All right, let's try something here. There we go. That will hopefully well, it's like just that's the my camera. I think it's hopefully in focus. That's like just at the edge. So we're gonna go with it. Okay, so C6 is next. C6 is C6 is what I just did. So now it says IC. Does it really want me to do SC1? Yeah, it does. Okay. It does warn you to not leave the soldering iron on for an excessively long amount of time. So, alright. So it does warn you to make sure you have the notch lined up. Like so. Alright, it would help if the leads weren't bent at such an angle. So the notch lines up with the notch. And there we go. In fact, that kind of feels like it's going to hopefully stay in place. So the notch is lined up with the notch. All right, well. Okay, so this is where I'm going to solder one of the leads. Or actually, you know, here's what I'm going to do. I'll very carefully bend two of the leads so that the chip stays in place when I turn it over. Like so. And now I am going to be ready for soldering. And I'm going to solder the opposite two corners. And help if I could actually see what I was doing. And then I'm going to carefully bend up on these two legs that I've bent over. And solder them. All right, and that would be the IC. Take a look at the joints. All right, looks like those are, well, it kind of looks like a, like have a bridge there. So let me, and looks like that pad needs a little bit more solder here. All right, that looks, I think that looks decent on the IC. The VR1 is the next component, which is the volume. So I will now solder these legs into place. Battery wires out of the way. I think those are, well, actually, you know, the center probably actually is an electrical connection too. I think these other two pads are probably because they've had two different size potentiometers for this kit. And probably so they can put whichever one is cheaper in the kit. I think of where it is, I can show you what the other one that could go there probably looks like. All right, the next component they want us to put is R9. R9 is here, and R9 is a 10K ohm, 5%. So R9. Looks like R9 is, oh, not the one I pulled off the card. R9 looks like it is brown, black, orange, gold. All right. I'll just kind of bend the leads over. No fancy lead forming tool here. But we'll just kind of poke it through. And for efficiency's sake, let me see. I think it now also wants us to do R8, which is an identical resistor. So I'm going to go ahead and, for efficiency's sake, I'm going to go ahead and put several components on the board. And kind of bending the leads over on the bottom so they'll stay in. And wants us to add a jumper wire, see figure F. Cut a 1-inch wire and strip an 1/8 inch off the insulation of both ends. All right, well, I think, well, I'm going to cut a wire slightly longer than they say to, so that I actually have a little bit more to stick through the board. Jumper wire, jumper wire. I think that was marked on the board over here. Well, let's... Also, another common practice is to use the clippings from one of the other components. But I will humor them and we'll actually add a jumper wire. the instruction, it does not elaborate why, but, well, whatever. Okay. This is R4. I'll set R. Actually, let me go and put R4 on the board because it's come off the came off the card. Let me go and put it on the board. R4 goes here, like so. Try to get it centered on its legend or its box. There we go. Well, whatever. Okay. All right, back to the instructions. The instructions say R7 is next. So R7 is here. R6 is right here. And all right, that's probably enough components for one batch. So we'll start here. And I just had one of the resistors fall off the board. Right. I think I know which one fell off the board, but all right, let's see what those look like so far. Well, they're not perfect, but well, they'll work. I mean, one thing I could do to kind of tidy this resistor up is apply a little heat and see if I can't gently pull the lead down with the operative word being gently. Then I'll simply just double check that the solder joints still look good, which they do. Right. I'll solder these next resistors on. I think the one that went here is the one that fell off the board. Luckily, it's just on the table. And we'll put the color stripe guide to the test. There we go. Let me clean this solder up off the board. There we go. All right, I guess I can actually go ahead and solder this one and this jumper wire. Oh, and that was plastic from somewhere. Oh. Oh, I melted my board holder. Okay, well, those things happen. All right, and we check. I think everything is soldered on so far. So we can clip, 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 clip leads. Clip. 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 All right. Well, looks like R4, R4, yeah, it's fine. Okay, so R6, I believe, is the one that fell out. The resistor is a... looks like red, red, orange, and R6 is... red, red, orange. Okay. Well, actually, looking at where the resistor, where R6 is, it is... the one. So I will pin the leads better so that it does not fall out this time. Well, I have to admit, the components that came with this kit are cheap. I mean, for this kit, it's fine, but quite honestly, I like resistors with slightly thicker leads. Makes some soldering so much easier. Well, I think I am going to clean up the leads just a little bit. And if you're wondering, I am only just very gently pulling on the leads. the resistors were kind of... Alright, so there we go. So that's all the components that were on the first page, except one. C3. So, electrolytic, so you want to make sure the negative stripe is on the negative side. And snip. Snip. Alright, there we go. There, that's all the components on the first page, as well as one of the ones from the second page, because I accidentally pulled it off. So, alright, so there we go. So far, we have the jumper wire, R4, R6, R7, our volume, C3, C5, C6, R9, R8, and RIC. So on the second page, it tells us to do R3, which is... right up here. And R2. Which, yep, it is. It's a bigger resistor. It's actually a half-watt resistor, whereas all the others are quarter-watt. C2. C2 is... Alright, another electrolytic, so we want to make sure the stripe is on the negative side. And Q1 and Q2. Alright. I think these will, I'll solder these on. That's honestly enough parts. Alright, so for the transistors, you let the, yep. So just kind of have to bend the pins to match. So, well, let's see if I can't find my, oh, there they are. Find my pliers to kind of help me bend the pins. I can get them close to the holes. So basically, for the transistor on these silk screens, there's a flat side on the transistor and a flat side on the silk screen. And you line them up. Like so. Probably a little clearer from the top view. And basically, all I'm doing, I'm just kind of approximating, bending it away from the board until it's close enough that I can get it through the holes. And then, if it's close enough, then I can kind of wiggle it in the holes. I don't want to put too much stress on it. And then actually those will kind of stay in place more or less, but I'll kind of bend one of the pins over. So I'm going to go ahead and solder those on before I go to anything else. And also I noticed a few of these connections that appear to be kind of not the greatest. So I'm going to kind of, well, actually, you know that maybe that one's better than I thought it was. Yeah, I'll fix the other lead of this resistor here in a moment. Solder joint doesn't look that great. But also I think the resistor drooped down more than I wanted it to, so we'll do a twofer. There we go. Oh, I just realized well, unfortunately, given where my camera is, some of these are, I'll flip the board around. I just realized those last component or two was probably off screen for you. Oh, that doesn't look good. Yeah, that looks like a bridge. All right, well, we could just use a little solder wick to pull some of that solder away. look at that, and okay, that looks better. All right, let me flip this around. Oh, well, actually, this will also help me not hit the quad hands, because now the iron's on the side away from that. And you can see again. One of these solder joints looks kind of meh. Maybe not. All right. Looks like I did solder everything that I put on the board. Oh, kind of running low on the included solder. Oh, actually, I think there's the solder joint I saw that was kind of... All right, so now I think we've got a few more components to put on the board. Oh yeah, we've got some an LED, or two LEDs. So LED 1. Okay, LEDs are polarized, and there is a little flat side to it. Not the most pronounced flat side, but there it is. And of course the LED is on the other side of the board. So you take the flat side on the silk screen and the flat side on the LED line up like so, but you can kind of see the flat side is there. It's just not the most pronounced, but that's fine. Okay, R5 is the next resistor, which of course is, oh, yeah, okay, R5. Where's R5? Okay, R5. R4 is right, nope, that's R1. Oh, R4 already did. That's right. That's the one that I pulled off the card. So C2. Oh, C4. C4. That's this little cute little ceramic cap, which is not polarized. C4, C1. I think I'll just solder these three components. C1 is an electrolytic, so it is polarized. And it looks like it is same polarity as C2 beside it, which is good. All right, so let's just solder those three components. Like so. Smaller pad should heat up quicker. And, well, I gotta solder this in a way that, because of the smaller pad size, that I don't bridge inadvertently. And then the reason why I'm waiting on the ceramic cap is because it's falling out. Oh, I got one more component to solder, I just realized. But it's on the wrong side of the board for you to see, but I'm afraid I'll risk it falling out if I move the board, so I'm just going to solder it. It's one of the LEDs. Because what siren would be complete without an LED? Well, actually, I think it'd be what siren would be complete without two LEDs. So the next components are R1, the LED 2, and one more jumper wire. I think was the jumper wire I was supposed to put in first, but it doesn't matter because, well, this isn't a project where you power it up midstream to test. All right, and let's solder these last three components on. And then we attach the speaker, and then we power it up. Oh, well, that's not cool. Oh, that's just a blob of solder. Okay. Wow. You must really know how much solder you're going to go through, because... All right. And I don't know why instructions don't say why there's an R6A and a something else. Oh. Because there's desolder practice. Aha. Sneaky, sneaky. Alright, so I think now this is where they want me to probably take... it might be more wire than I want. But now we gotta add the speaker. And I'm going to use this wonderful wire they included. Well, I guess at least one thing it will... It does seem to work better when you're soldering it from the other side. Alright, so the way you put this together is... Alright, so we put these wires up through this hole, like so. And then we pass them back down. And I do believe, from what I can see, that the speaker is not polarized, which is good because the speaker is not marked. All right, so now that we got that, so let me see here. Bend that one over that way, and bend that one over this way. So hopefully, now when I solder those two wires, and I have been using their provided solder for this. I have to say, my first thoughts as I'm wrapping this up is that, I mean, the kit, it's an okay kit. I think with some better solder, and quite honestly, maybe if the kit had you use some solder flux, that might also help the solder, as if they maybe taught you about solder flux, that would help. But also, I think if the components were slightly better, even if it increased the cost of the kit by $1, I think it would be a better kit overall. But I guess they were probably going for cheapest Learn to solder kit. So anyways, I would say if you're going to get one of these, I would recommend not using their solder and use some better solder. Alright, so now we gotta add the components to the speaker. Take the board out of the board holder. Guess we'll put a lead here. Okay, it looks like the speaker is polarized, but the circuit is not. So I guess this is one of those things that if it was backwards, the sound would be out of phase. But I guess given this circuit, I don't know that you would know that the sound was out of phase, because you don't have stereo sound. So maybe that's why they don't have a polarity marked on the board. Oh. There's one lead, and there's the other lead. Also, if you get one of these kits, I would use some better wire, because the insulation on this wire they include melts at an awfully low temperature. All right. Well, that appears to be the circuit. So I think I will put the battery in and let's see if it works. Oh yeah, flickering light warning. Yeah, that does sound a bit fast, doesn't it? Okay. Let's do their little practice desoldering thing. So basically, on the last page, they well, you get to do some desoldering practice, component replacement. Yay! Okay, remove the battery. That's an important step. And for the record, one of my soldering disasters last week could have been caused by me not unplugging a power adapter, but if you very carefully watch the video, you can see that I do unplug it. It's just the unplugging was off the screen, but you can see me jerk the board pulling out the power adapter. So that current came from the desoldering gun, not the power adapter. So anyways, we need to replace R4 and R6. So I'm going to, honestly, all right, so I'm just going to use some solder wick. And honestly, I will give their solder wick a try. I guess it's only fair that I give their solder wick a try, even though it probably is not that great. Yeah, it's not that great. Okay, now that was really nice. Yeah, that pretty much sucked up all the solder. And then the goot wick, I know it'll wick the rest of this up. This is why Bruce at Franca's Creations recommends this. I mean, look at that. That is a beautiful. Whoop. Still attached here, just a wee little bit on this side. Oh, there we go. It came out. Okay, so that was R4. All right, so R4. So we replace that with R4A. And now we'll solder. Not sure why I got solder there, but at least I'm gonna make it look pretty. All right, so there's our 4A on the board. And and let's see, R6 is these two. Yep, all right. Oh yeah, helps to oh, nice. I see how the self-cleaning action works. So basically, when you press the button, it ejects the solder that it's picked up. I think it works better if you pick up. It works if you pick up enough solder, it works better. But anyways, so I desoldered that. I'll kind of clean this up here with the goot wick. And now we'll get our 6A in. All right. Last but not least, all right, and we'll snip the leads. And now, for the final test. I think that sounds right. Not that I've ever been to England. All right. So we have our Learn to Solder kit assembled. So I guess my thoughts about it. Just let me turn soldering station off here. Set some things off to the side so I have a little room to set things on. Over here. All right. Well, first of all, Okay, I guess the good. Well, I'll take those off because I've done soldering. All right, the good. I mean, it was a fairly easy kit to understand. It does have. It came with all the components, even if they weren't the greatest. Although maybe that's a neutral. I mean, the directions. This looks like. I guess basically there's 14 pages of instructions, including the parts list and some guides. And then there's a quiz on the back with the answers upside down. So just they're there. Let's see here. Let's go through the questions. Well, no, we'll go through them in a moment. The components, I guess, were laid out decently, although I wish the capacitors were marked in a way so that when the capacitor was on the card, you could still see the location references. But, I mean, they are marked, and the board silkscreen had which capacitors went where. So I guess it's not the worst thing in the world. The kit did come with just enough solder. And in fact, it would have even less if I hadn't have used some of my own solder to give that a try. But it looks like I ended up with, because this little soldering mat has metric on it, about 8 centimeters of solder remaining. And this was supposedly 5 feet of solder to begin with. So I don't know. I'm going to call that neutral because it came with all the parts, but you might need more solder. And quite honestly, the solder, it's okay solder. It did its job, but honestly, I think I would recommend if you're going to put this together to maybe use one of these other solders like the Kester K100D or this other Kester that I'll put in the YouTube description and my website of things I mentioned, because I don't remember what the part number is right offhand, but this is the 96.5 3.5. So I guess that's the good. The neutral is, yeah, might not be enough solder that comes with the kit. And I don't think this is the way this kit went together. I don't know what age range they claim. That's one thing that wasn't really on the instructions. Okay, it does not say on the instructions. Oh, I've got the Amazon page pulled up. Let's see if the Amazon page has a recommended age range. Let's see here. That's not. Let's see, choking hazard, small parts, not for children under 3 years. Yeah, I think I could definitely say this is not for children under 3 years. Okay, manufacturer recommended age 12 to 16 years. Okay, if your 12 to 16-year-old is impatient, this is not the kit for them. Maybe it would be fine if you sourced some better components that weren't so fiddly. The leads on these components were awfully thin compared to better components you might buy from an electronics distributor. In fact, I might actually... Okay, here's one of the resistors I pulled off. And... Okay, so let me actually grab a resistor out of my Zoxbox parts kit. Or parts box. It's not really a kit. And I'll show you what I mean. I don't, granted, I'm just pulling these out because they're the first ones I came to they may not match size-wise for a resistor that's in the kit, but it's to show you the lead size difference. And I think if you see, these leads they're much thicker, and these actually, when you bend them over, these thicker leads, when you bend them over, they actually stay in place. Whereas these ones, even though I bent them over, they still didn't really want to stay in the board. So honestly, unless your 12 to 16-year-old is really patient, I would say you might source some other resistors. Now granted, you might, if you have a resistor assortment, especially if it's got some decent resistors in it, you may have these resistors and capacitors in better sizes. The transistors, their leads were fine. They actually, I didn't really need to bend them over for them to stay because of the way they go in, but those leads were nice. The LEDs, those leads were fine. Obviously, the IC leads were fine too. But it was just the resistor and capacitor leads. They were really cheap. So that would be kind of a strike against. Maybe I might even recommend maybe a slightly older age range, and they might be able to get over a little more imperfections. Also, I didn't really like the solder wick they included. It was really cheap. I would recommend getting some goot wick, because this actually has flux in it, which I think helps it wick better. In fact, my goot wick actually wicked way better than what was included in the kit. So that would be something I would probably recommend, as well as using your own solder. And quite honestly, a little bit of solder flux, which wasn't included, might actually have helped some too. But probably the biggest thing, which that wire that was included, I'm actually kind of glad I found these gloves. They're supposedly anti-static gloves. I won't be listing a part number for them because they are currently not available, and I don't know if they will be available again. But anyways, yeah, you can see where I got all the insulation stuck to my gloves. So I was actually kind of glad I was wearing these instead of what I was wearing last time, which were just some nitrile gloves, because I'd have probably melted the nitrile gloves, and that would have hurt. Not that I could. I can feel the heat through these too. Anyways, overall though, it did work. This does sound like a European siren for what I know. Although the volume knob's a bit weird, because adjusting the volume didn't really seem to, it did adjust the volume, but the pitch is going up too. I also use some contact cleaner in the volume knob, which is kind of sad considering it's a brand new potentiometer. So it's not the greatest potentiometer. Overall though, I guess it's a neat little kit. It makes noise. It's got flashing lights. I do feel like I got a chance to practice on something that if I totally messed up, it wasn't the end of the world. And in fact, I did mess up a little, but I was able to fix it. Because at one point, I think I did tear a trace up, but I was able to tack it back down with solder. So, yeah, I got my solder stuck to the pad, and I pulled when I should have still continued to apply heat. So overall, though, I guess that's a neat little kit. I think if you got one, especially if you got one for like $9, and got your own solder and used your own solder and used your own solder wick, that would you'd probably be happier assembling it. And then maybe if you had some better resistors. Probably. But I got the resistors, they're in, the resistors worked. They were just harder to keep in the board. So overall, though, a great project. And I just realized that I went way over my streaming time. So I am going to call this stream to an end so that I can go call my grandparents before they worry about me. So anyways, take care. I'll see you in about an hour for Sunday Night Games. Talk to you later. Bye.